All right, so this talk is about scaling Bumble's design system. And we're gonna not go that deep how you do that, but we're gonna just prompt some problems and the approach that we're using to a completely different way. So if you're a designer, please don't kill me after this talk. Right, so Raul. Actually an iOS and design system engineer at Bumble. I started iOS when, using ActionScript 3.0. So if you, that's what I'm gonna. If you know what is ActionScript, probably is too old, and this was way before Steve Jobs banned, the Flash from the platform. I'm also a sneaker collector, and this is just my daily usage. So that's more that you can expect. Jordans. All right, so Bumble's design system. As you can imagine, Bumble is a huge company. That's a lot of products that we have. The Bumble app. We have Badoo. We have Bumble for Friends, and you can go on and on. So you can expect that it's really, really big design system. But how we manage that? So internally, we have something that's called a Cosmos. Cosmos is the name of the design system. It suits iOS, Android, web for desktop and mobile, and also some marketing layers. It's something quite big. And as every single design system is built on top of atomic design, and we use semantic tokens as a core for the design system. Does anyone who knows what semantic tokens is? All right, so that's the designer does, but yeah, we use semantic tokens as a core. As I say, common features like build on atomic design, which is really important if you want to scale your components, you want to have very fast updates. That's something that you should be going with. Semantic tokens, which is, for those who doesn't know, when you go to design, you have something that's called core values, where you have your black, red, whatever colors you decide to go. To access these colors, we create something that's called core tokens. Core tokens can be black 70, or black is always going to be black, sorry, gray 70, gray 100, and on top of that you have semantic tokens, which is going to be primary background, second background. That's what is semantic token. But our design system also supports themes. There's a really heavy automation that we run there. It's completely native, so it means that on iOS we run Swift, and Android we run Kotlin. And this is important, we have a really, really rich documentation, but that lives outside the design environment. So that's more or less how it looks like. So at this base, we have Figma. We have a lot of exporters that are going to be working for us and going to be exporting native code. So when a designer triggers an update, technically we are able to export all the single code that we want to for our platforms. That's our design system. Beautiful, native, that's what I expect. However, this approach does not always scale. And there's a bottleneck there that the majority of the companies probably don't have it. It's just our use case. And this is discoverability. When you grow your company, your product base, trying to figure out where your components are is really, really hard. Because you have documentation for designers, you have documentation for engineers. iOS has one way of doing, Android has a different way of doing, and things just don't connect to each other. There's another problem, that's the part that kills me to say, but semantic tokens don't actually scale that much. They are really good, they are the foundation for whatever you use, and they still the standard for the market. But for a use case, semantic tokens was a little bit limited, so we have to go a little bit further than that. And that's my favorite part. Semantic tokens actually opens the door for incorrect implementations, because your components could be using, for instance, different background color expecting. You could be using primary color, whatever decides. But semantic tokens on your implementation gives that door, so anyone can actually be doing anything that they want to. So if semantic tokens are limited, how do we scale that? And if we talk about semantics, how you go further than that? What's next? That's when you call to something called component tokens. What are component tokens? So this is not a new concept, it's already there. There's a lot of people probably talking about it, but component tokens means that every single component has their own single set of tokens, which means that if you have a proper color background that represents your component, that should be represented in your design. If you have sizing, whatever you decide, it should be represent that. As I say, if it's a property, it's a token. So whatever is there in the component and the design should be translated to a token so that we have completely control of that. And because you're using component tokens, that also means that your components could have themes. So you're not just attached to your semantic tokens to change the whole look and feel of your application. Now your components become completely independent where you can have your own set of themes when that's useful. Imagine that you have, for instance, Halloween is coming. We have Christmas, that's going to be soon as well. So instead of trying to change the whole look and feel, your whole graph, you just have your component being updated for the given particular theme season that you're trying to ship. That's how a component token look like. So you have that a component that we call an action card. And every single property there, in this case, which is a color, is given by a token. So you have background, you have title, icon, description, overlays. Every single thing needs to be a token. It can become overwhelming. That's one downside of that. We're going to speak later. But every single property should be represented as a token. How that looks like in real life. So if you're familiar with semantic tokens, on the left, that's what you have. You have brand primary, you have your color black, and then you have the real value. But semantic tokens is, component tokens is just another layer on top of that. It doesn't suit everyone, but in our case scenario, it suits really well. So you have your semantic token, is still there, but your component brings the whole isolation that you need that. But we are used to an industry that says every single component on your design system is built on top of semantic tokens. So how you go from there to, hey, now I want to use component tokens. I want to build a SwiftUI first design system that uses all those benefits. I want to create an architecture that prevent people to use things that they should not be using. To do that, we need to first dig a little bit in how SwiftUI works and how Apple does customization. So this is a very familiar case scenario where we have a toggle. So how SwiftUI works? The toggle customization, for instance, is a protocol-based, and that is for the whole components that Apple offer. So Apple has a protocol that says, hey, this is what I have for you. It's a configuration. And from this configuration, you can do whatever you want to. And because I'm very flexible, I'm offering you a protocol, you can change whatever you want to using view modifiers for customization. So that's a very, very common workflow, and that's how people does, and it's not wrong. However, there's a few problems with that. If you think about design systems, this is not very nice to have, because what Apple built SwiftUI, the same thing for UIKit, where the whole problem becomes much more like familiar with, like UIKit is different from UIKit. So UIKit is the foundation for a design system, but Apple calls UIKit the foundation for the first UI library. So what Apple did with SwiftUI was, I'm going to give you all the APIs you need to build your own design system to suit all your needs. However, because I'm offering a OS customization level, I need to be as much as generic as I can so you can build whatever you want to. The other problem is if you try to mimicate the whole thing about how Apple does, because that's what we've been trying for years, right? We are in the 5th or 6th version of SwiftUI, and we always trying to go to the same way where we're gonna end up with like a lot of articles and people say like do this and that, and you have what? You have any views everywhere. That's a very debate, and the community says any views do not have performance issues, but trying to have a list with 500 items. And every single component in your items is actually a design system component, erasing to any view, losing the identity, so it becomes quite like a bottleneck. For small components, that's fine, but the reality is it doesn't actually scale very much. And the problem with protocol approach is you have a decentralized implementation. So in a scenario where you have loads of components, and if you start mimicking Apple's API, I have this protocol for my avatar, and this is my configuration base, so I try to replicate this and that. Like I have a square implementation, I have a circle implementation, I have an hexagon implementation. You have 3 different implementations in 3 different places. This becomes a problem because the centralized implementation already is a backdoor for anyone to do whatever they want to. And when we talk about accessibility is you have to reproduce accessibility in 3 different places, 4 different places, how many customizations you have. There's a way to overcome this problem, but it's not ideal. When you say like the Apple offers a very flexible way of customizing, like without checking the code, you can tell that the second one is actually a toggle. It's a navigation, probably, the navigation cell, but you can customize it at any level. And for Bumble's use case, this is a very, very a hard problem, because you can create any ad hoc implementations. And when you talk about ad hoc implementations, that means that people can just create their own styles, which not belongs to the design system. And when you're a company and you have a brand, you have a reputation to keep, you're just shipping things and should not be there. So this, unfortunately, is a very, way that doesn't work for us. So how you go from protocol-based implementations to this whole thing that I just said that about component tokens, how you do that all together. I think the best way to do that, we jump on a demo and we see how it works. Yeah, let me see. By the way, I'm using Figma slides. So if you see any bugs, bless you. All right, so let's just launch our demo app. Oops, that's on my phone. Simulator. Should be launched anytime soon if you're using Xcode Beta. All right, so I have this app. How many of you actually knows One Piece? So we should catch up afterwards. So this is just a small app that kind of represents the Bumble scenarios when it comes to high-level component customization. But just for the sake of the demo, this is just a small app. You just can click and you have your elements there. So it has a very small design system here that has the avatar group, avatar, views, and some text. So the good thing is about this approach is that you are not just entitled to dark and light themes. If I try to change here, my simulator, I have dark theme, right? But I can also have whatever theme I decide to on my demo or my app, and things just works nicely. And you can override the themes or whatever like that. This is quite simple. So nothing special about the demo. We've seen this before in so many places, but let's just dig a little bit and go deep on actually how the component looks like. So trying to mimic an Apple API without using protocols is a trick situation, but it's not impossible. So here I have a component, for instance, which is the avatar that we just saw, which is right here. So, and my avatar has a property called shape. And if I want to use my shape, I can just choose circle or square. If you're way familiar with how Apple UI components work, technically it's the same, because it's supposed to be a protocol, right? But it's just not a protocol. I'm going to give you the tip. Size, whatever I decide to, is also a size. But again, it's not using Apple protocol. So how all this works? If you come to my component here, when I talk about the component approach for the tokens, this is what you have. You have your component, which is my case is avatar, and my component declares all the tokens that are needed for customization. So if I have a sizing, which is small, medium, or large, my component knows exactly the tokens that are needed to be driven by that. Border radius, color, fonts, every single property on my component is declared by a token. So when I offered to my consumers, which it could be, my internal engineers, could be someone that we have a partnership with, and say, hey, listen, I have this component, and you can customize the way you want to. But because my component is already expecting some sort of tokens, you can customize in a certain way, but not go that far. Because if you check here, when you create a styling, you have complete isolation about your component. You cannot see semantic tokens anymore. You only see component tokens. And your style is just, a structure, not a protocol, but a contract that you declare avoiding protocols, which is very simple. There's no much complexity there. But when it comes to consumption about that, it's just for a client implement components or design system engineers, what you can do is your protocol. We saw that tokens are literally just a pointer to a resource. So to integrate this kind of approach in your backend, which is from your application, you just have to parse that resource, and you can still use with key paths if you want to. Let me get it. You can still access those properties and customize. So for this avatar, every single property you see is actually driven by a component. But you might say, yeah, that's simple, that's nice, I've seen this before, but I really don't care. Show me something that's much more exciting. How many times you've been on a situation where your designer needs to update your colors or fonts or spacing, something changing, they require those kind of informations, right? If you use the semantic approach and they are trying to test avatar stuff, it will affect the whole application, right? And if you're using the base protocol with primitive value, which is color, you also get to a position that you cannot reflect that very much. So let's pretend that I'm a designer. And this file you see here is actually my Figma, right? So what I want to show is how this abstraction can be useful when you're trying to be fast with the things that you do. So let me just get here. Let me change this piece of code. Let's compile. If everything works fine, will be no error. All right. So we are back to our app. So let's say that my designer says, hey, I want to test some new colors for the avatar component, but how fast you can do that? Nowadays, I would be like, you do yourself, because I don't need to. Because we can just connect to an endpoint and have a design system that's actually driven by a server at this point. So if you don't think this is fun, let's try to change the colors of the avatar. Let's try to do with one hand. Oops. If you use Cursor AI, this is quite fun. Okay. So if I refresh my avatar, did I save it? I don't know. Probably not. Yeah, if I save, I can just change the avatar colors. And the interesting part here, React community have this for years and years and years. PhoneGap, if you know PhoneGap, has been this for years, but we never did this in the SwiftUI way. This is completely native. There's no protocols based there. This is SwiftUI working as SwiftUI and use the benefit of SwiftUI, which is environments. So you can keep going, you can change whatever you want to, and that's how things works. Back to the presentation. Yeah, that's the one. All right, so let's try to summarize the demo that I did. So when I say component token approach and ditching the protocols approach, I'm actually giving the instruction to say, hey, try structures, try type safe, go away from what protocols. Protocols, we know that is really slow when you're trying to reach, launch the application. There's a lot of conformance happening there. Try to actually declare the components that you have and the tokens that you're expecting. We do that in an automated way. So when someone updates something, we just run automation and generate all the code that we are expecting. So technically, this doesn't even exist for engineers. It's all automated. What are the benefits? When you declare your components, properties, and exactly the set of tokens you're expecting, you're reducing your ad hoc implementations. Ad hoc means that you have less headaches in the long term because all the styles you're expecting exist in your design system. You just don't need to start erasing from your code base. Because we are using a structured approach, there's no more protocols. There's a single implementation for your component, which means that it lives in the single source. So if you need to update one thing, which let's say that now we need a border. The border is already inside the same place, so you don't have to go to 3, 4, 5, 6, 7 implementations anymore. You just stay with a single one. And everyone thinks that just because you're not using protocols, you cannot use view modifiers, but actually view modifiers is a function inside your components that can receive anything. So if you work with structures, why you cannot write this kind of code? If you're familiar with how protocol, the customization for protocol is the same, but you just have some constraints. But if you use actually, strong type, this is much better and much more performant as well. And accessibility is a tricky one because it's already there, right? It means that if you have your code in a single place, accessibility is there. You don't have to keep replicating accessibility and get to a point where people don't even know if a component has accessibility or not. Centralized implementations means that accessibility is always available at the time of the creation of the component. So benefits from going with this approach: restricted customization. Because you have tokens, component tokens, and you're expecting a very specific subset of tokens, your components become much more restricted and tied to your design system rules, which is exactly what we want to. We don't want a UI kit again. We are building a design system, and that's good. Fast updates. I don't have that implemented because it takes a while to do that, but who says that actually you have to redeploy a whole graph of styles when you're doing your customization? What if you could just say, hey, I'm having a seasonal, campaign, or I have a partner, I have a a new membership. Remotely, you just update the piece of information that you're looking for. So you don't need to redeploy the whole styles for your app. You just deploy parts of the graph. This is way faster than just doing the whole routine that you use it to. And there's no any views there, which is the things that we most love. Ditch any views if you can. And in this approach, shows you how you could do that. Probably going to read a scenario you have to use that. But scaling is not just about code. It's also about discoverability. And one of the biggest problems is where I can find my component, where is my avatar, where is my button, where is the documentation lives. And I think this is my favorite part here because we solve this with Figma Dev Mode. How many of you use Figma Dev Mode? We should push for more, but so this year Figma announced Figma Dev Mode, which is quite incredible. If you think about Dreamweaver we are going back on time. And I like that, to be honest. So Figma Dev Mode has a cheaper license that you can have and allows you to push your code via Code Connect, so you have documentation available straight away there. You don't have to go, for instance, to Storybook, sorry about that, Supernova, any other ones. If developers are already familiar with Figma because they have to go there, why not just using Figma for that, right? Dev Mode allows you to play, has a playground, so developers can also, play around, trying to see the customizations. And when you're a design system engineer, or maybe just engineer, you just push the code so it matches exactly the design they're looking for. And the benefits are you have a clear status on that sense, because the dev mode has a feature that when the design is ready, developers know, because they have a flag that says ready for development. When a feature is done with development, designers know, because again, there's another flag that says, hey, this is done, you can start testing. And because of the dynamic playground, developers can play and trying to figure out what's going on there. And as everything lives on Figma, in this case, your source of truth becomes one. Means less back and forwards between applications, and just make sure that everything is just right there when they need. So, quick demo about that, because why not? We love demos here. So this is Figma Dev Mode for a component. So this is the simple design system from Figma. And I took the liberty to, why not just implement some SwiftUI components and upload them? No, it's a private, like a fork, so no one's going to complain, right? So this is, I cannot zoom, unfortunately, but this is how the component looks like. If I open my playground, I can just play around and say, hey, I don't want to use image anymore. I can use some initials, as the component is saying. The sizes, I can just play around, and my whole code is going to be reflected there, to reflect what I want to. And when it comes to shapes, it just changed the modify that I'm looking for. So if you think about a huge company trying to scale a project and trying to go to a situation have every single information needs to be available just right there. This is what you need. You don't need to have developers switching contexts, because believe it or not, you need to pay license for documentation. So if your documentation is in the place that you already pay for, that's a plus, right? So, conclusion. I know it's a lot. Bear with me. Talk with me if you want to, but semantic tokens are not the last layer. Or there's a lot of advantage. That's what the industry uses. However, for us, it was a bottleneck because we need to go further. We need to go beyond that. The customization that you see that the avatar could just be uploaded just without changing much code and without requiring engineers to do any code anymore. If you combine that with SwiftUI, and you can create a very powerful design system that is driven by your Figma, actually. So you can go to places where we thought that would not be possible, and React has been there for quite a while. So thank you.